Thanks for the introduction. Today I want to address PLANTSIGHT and provide some information around operational intelligence and process simulation. So under this theme track of digital transformation, I want to address the importance of the digital twin here. The real digital representation of the real plant. So what we look at is the information which is created in the very early phases of an engineering project, which will then be handed over, providing the benefits for operations phase. And the benefits there are for all stakeholders, from the highest role regarding the plant operations to those other important roles regarding maintenance, process production, inspection, and modification. We take this reference statement from ARC Advisory Council. They say that true digital twins must bring together context and characteristic data with real-time and operational data, because that's where the value is found in a true digital twin. If we look at the digital representation here, we can break this down into a granular part. So we can look at a single asset, or we can bring a number of assets into the process that they're part of, or the system that they're part of. And then we can use all of those systems to build up to an entire plant so that we have a full digital twin representation of the real operating facility. And the important part about this is when changes occur, whether it's from the automation system making changes or whether it's from engineering driving change, it's extremely important that this information is recycled and continuously fed back into the digital twin. That means any changes done in the automation system are fed back into the digital twin, and anything done in the engineering authoring systems are also brought back into the digital twin. And I'll elaborate a little bit on this topic as we move forward. The most important value here is to be able to generate reliable insights around predictability and performance in order that any changes for optimization, maintenance schedules, the recommended maintenance schedules, or what's looking like we can't wait until that time, that we have those insights to make reliable decisions. So the asset integrity, extremely important to monitor these critical objects, because without these, the availability of the plant is going to be impacted, production is going to fall, and we need to do some action there. Ideally, we want to look at this on a predictive level so that we can see from trends what's happening and be able to make some decisions along the way. The important part here is bringing all of the engineering, the static information, together in one environment, and then by connecting through sensory devices to the operating plant, we can do a comparison to say, this is how I'm designed to operate, and this is how I am operating. And we can make some analysis there, because over time, conditions will change in any plant, in any process plant, that will mean decisions have to be made based on that context that we bring together from one environment. So from Siemens, that environment is PLANTSIGHT, where we see on the left-hand side what I just referred to as the static data. That's the data which is coming from early designs, from 1D data sheets, from 2D documents such as PNIDs or other schematic drawings, and 3D models, in order that we can look at the object on the symbology on the 2D drawing and look at it in its actual physical environment so that we can make best decisions relating to all objects. When we look at the right-hand side here, we see this is from the DCS, alarm management, the real-time data which is being collected from sensory devices. This is such as noise, vibration. And then we look at the trending information, historical data. What do we know about this object in its system within the facility? And as we can see around the outside here, this is a continuous process through the life cycle of the plant. Traditionally, a handover is found at the end of the CapEx phase of a new development, what we refer to as in the EPC phase. With PLANTSIGHT, we can start that information handover continuously at a very early stage to give the stakeholders in operations a real view of the plant as it goes through design, into construction, through commissioning, and pre-production. And of course, plants having 30, 40 years upwards operating life cycle, then this is a continuous process as changes occur. Changes either from process conditions or from design changes. The subject topic for this presentation is operational intelligence and process simulations. The demonstration that we're going to see is going to focus on some critical equipment in a plant and a use case where some issues have been raised. And the second one, it's going to look at a process simulation where some environmental restrictions are driving the need to make some adjustments, and how simulation and optimization can use this data available in PLANTSIGHT to make better decisions. So with that, I'd like to hand over to my colleague, Gert, who will provide us with that demonstration.
Thank you, Nigel. I will show you now a few examples of the operational intelligence view in PLANTSIGHT. Here we can see an overview of all our plants that we are currently monitoring and controlling. So on an enterprise level, provides a nice view of all the productions of all our plants. Critical equipments, plants that need really attention, that are underperforming. On the bottom right, we have some recommendations from people on the field or from analytics. And here on top, we see some ties for each plant. And in this case, Karlsruhe really behaves bad, as we see its health and maintenance status is not that good. PLANTSIGHT can calculate these KPIs because it's connecting to all the data sources, the engineering data and the operational data like historians and maintenance systems, and combine and aggregate all this information, and so we can calculate proper KPIs. So when I clicked on the Karlsruhe tile, we see now the details of a Karlsruhe plant. Again, similar view, all the assets or critical equipments that are not performing well. We have the recommendations in context only for Karlsruhe, and here we have all our equipments organized by class, and it's some of these KPIs. We notice that the pumps really have some issues as well, but for this demonstration I would like to focus on the T101 on the turbine. Although I could click here for the details of turbine T101, I would like just to go through the turbine list to show you that PLANTSIGHT can also give you an overview of all the turbines that are currently in operations, and we can make comparisons, who is performing well and so on. Here for the T101 is appearing the first in the list. That is because we want to attract the attention to the underperformers. So here in this turbine for T101, we see there indeed have one failed starts the last 30 days. And there have been some alarms triggered the last 24 hours. And due to some low loop oil pressure. So I will click again on the turbine to get all the details of this specific turbine. And so you can see that PLANTSIGHT really provides a holistic view of all your assets and equipment. So you can drill in from the top level, complete towards the detail of one equipment like this turbine. Now you can clearly see the health is really underperforming, and that is due to the poor efficiencies that are shown here, coming from the aggregated data that has been collected from our sensors. And so causing higher power to drive of the turbine than it is designed. And so likely this could result in a failure if we don't look at the real cause here. So from the analytics, we see low loop oil pressure, and it recommends that we check the instrumentation for false alarms or check for a plugged filter. As mentioned, we see that the efficiency of the turbine is really low, and even at 40% efficiency running. So we'll go to the process information to have a detailed view on the lubrication oil diagram. And we see here from currently that there is only 1.9 bar of oil supply pressure for lubrication, while it is designed to normal operation should be at 2 bar. So this already gives us a good indication. We can now open up the trend to show some history. Now from the historian information, you can see that 2-3 weeks ago it started to drop. So there is definitely something going on, and maybe we can find some more additional information. So just to show that the operational intelligence can also show more data than only real-time data or KPIs. For example, here we have all the documentation related to this turbine. You have access to the inventory list. So if spare parts are running out or running low, like here is a block valve, so we could make a ticket to the supply chain to procure more block valves. But for this loop oil pressure issue, we're going to have a look to our maintenance information and see what has happened. So we'll show also the closed issues. And I see in the past, indeed, there were some activities also to the service loop oil system done. So probably it's a longer term issue. We really need to make proper care of it. From the failure modes below, this can give some indications of what could cause this loop oil and what are the recommended actions. This is generated by reliability engineers. So if I go, for example, to the turbine, look here, turbine loop oil pump warm, you see here that the failure effect is exactly what the analytics is giving here. The loop oil pump has wearing, and the oil pressure drops. And so emergency oil pump starts and the control room would get alarms. And so this sounds really what is going on. And here we have then also the list of recommended actions we can take. So what I will do is I will create now a ticket to my colleague for a request to check if loop oil pump is warm. So he can drive now the appropriate actions further. And I will wait for this ticket, confirm the, and I will set it to acknowledged, so people will know that this is currently taken care of. So this is the first example of how operational intelligence view can help in people in operations. Now I would like to show another case for process simulation. And here we show how an analytic solution can be integrated with the operational intelligence. So here we have Siemens PSE provides the technology solutions and services for process simulation and production optimization, which is used by PLANTSIGHT. And what we have here is the flow process modeled with 12 wells, 2 separators and 2 compressors. So the flow process is a gas injection solution. The well set in the well field in the various blocks here is bringing a combination of product, oil and gas, and the excessive gas is sold off to the market, but also returned back into the well holes through the compressor process. This additional pressure into the reservoirs bring more product to the surface. So in this case, what we are going to show real-time process optimization and what would happen in case of a compressor fails. So I will simulate here now a compressor failure, and we can see now that the excessive gas here due to the failure of the compressor needs to be flared. So we have 1.9 million cubic feet per day gas flared, and that has a huge environmental impact and as well some compliance regulations that we need to take care of. So we want to stop the flaring as soon as possible. So what we'll do is now run a kind of optimization to find out what could be the new set points and routings that we can apply to stop the flaring but keep the production to a maximum. So when we see now at the results, see here we are currently producing 25,000 barrels of oil per day with 1.9 cubic feet per day of flaring. But here now we have, after the optimization, there are 2 plans that are proposed, a full optimization and a limited change. So the main difference here is a choice of changing the routing. So in full optimization we need to have a 3 route change of routes, and with the limited changes we only have 0. So for only, if you see with the limited plan, we only have 40 barrels less production, but we only need 3 gas lifts and 1 pressure drop without routing. So this is probably the best plan to apply because the less changes can be done faster, as well reducing the amount of risk. So each change takes some risk with it. And so only for 40 barrels we make not make sense to do a full optimization here. So we'll can now apply these changes. And when we look at the updates, the flaring goes back to 0, and we have now 23,000 barrels a day of production. And with that, I hand over back to you, Nigel. Thank you.
Thanks, Gert, for those demonstrations. So I'd like to end the session today with just some key takeaways from what you've seen from Siemens. So with PLANTSIGHT, we can provide a rapid decision-making tool that looks at the digital plant in a holistic manner, looking at the engineering, design information, comparing it with the real-time operating, in order that operations and maintenance can be optimized, production also. And when we look at the analytics available through aggregation of information and visualization, these decisions can be made without the need to take the plant out of production and how to maintain a continuous high level of availability. So a final slide here, PLANTSIGHT in a nutshell, data which is found in different silos, different formats, needs to be brought together in one environment. So collect it, consolidate it. Collaborate across the workforce using a single web-based tool to make the decisions or give you those insights in order that the decisions that you make with confidence. And at the bottom here is an indication of some benefits and expected levels which can be gained with PLANTSIGHT. Thank you.